Okay, the chemistry of life. Doesn't that sound very intriguing? Like, oh, I want to know more about the chemistry of life. And I know a lot of you love to complain about chemistry, but it's vital for us to understand how life can be, how life can exist, how our bodies can carry on functions. We need an understanding of chemistry. And we're going to talk about chemistry as it relates to the properties of water. Okay, just a reminder. I know you all, hopefully you remember this. Well, at least you might not have done hydrogen bonding, but you hopefully remember covalent and ionic bonding when I talk about that in a second. So water molecules form hydrogen bonds. So if you look up there, my little picture, remember, the water molecules are polar, which means their charges are unequal, okay? So you have on one end, you have your little tiny hydrogens that are positive, and on the other end, your oxygens exhibit more of a negative charge, and that's how they're bonded together. So we think water is kind of a sticky molecule, right? It'll stick to like the edges of our delicious frappuccino. They will, it seems to when you drop it on a penny, or it exhibits like that surface tension. We think of it as like a sticky molecule, and it's because of that hydrogen bonds. So we also call this polar covalent bonds. So the two atoms, the hydrogens, they share an electron. They share electrons, I should say, with oxygen, but it's unequal. Ready for this to blow your mind? Okay. Electrons don't stay in those orbitals. They bounce all over the place. I always think of electrons like a hyper kid with too much sugar, right? They're bouncing all over the place. So they don't stay in their shell. So they do share. They share those electrons, hydrogen and oxygen too, but it's not equal. So one might have two, one might have three, one might have one. So, because of that unequal sharing, you have this sort of unequal charges, right? Depending on where those electrons are, that changes the charge of the water molecule. We call this water's, like I said, it's polar. So the poles have different charges. The ends have different charges. Because of these polar covalent bonds, water has some pretty awesome characteristics. So not only are they polar covalent within the molecule, when they bond to other when they bond to other water molecules, we call that a hydrogen bond, okay? It's not a great bond, it's a weak bond, but because of the polar nature of the actual water molecules, they allow them they do stick together. I mean, you can pull a water molecule, you can pull a drop of water apart from another water molecule. Okay, let me say it again. Water is not, if you throw water, it scatters, right? Water can create steam, it can create ice. So the bonds are not strong, but they are present. Here we go, the 5 awesome characteristics of water, the elixir of life. So you've got cohesion, and I'm going to go through these. Cohesion and adhesion, it's a good solvent, lower density, high specific heat, high heat of vaporization. Hopefully you're just enamored and in love with water after I get through this. So cohesion and adhesion, right? Co and add. Those are the things I want you to know. So cohesion is when hydrogen bonding happens between two water molecules. And that's where you get your surface tension. When you think your water, you pour your water to the top and it doesn't quite go off because the water molecule is all sticking together. I always think of cohesion like middle school girls. They just want to hang out together, right? They just want to, so they are sticking together, together. Adhesion is when you have the hydrogen bonding between water and something else, like water climbing up a paper towel or a cloth, or water seems to, like when it forms droplets, like I said, on your delicious frappuccino. We also call that capillary action. Water seems at times to defy gravity. It can kind of like creep up your straw. It can creep up straws. It can creep up your capillaries. It can creep up into the different vessels of plants that we'll talk about. It looks like it can defy gravity because it can stick to other substances. So here we go. So water needs to get to the top of the trees. Am I right? Because that's where photosynthesis happens. Photosynthesis happens for the most part in those leaves, in those green leaves. So in order for that to happen, water needs to be able to creep up the plant. We'll talk more about transpiration later, but know that cohesion and adhesion is a vital part of getting water uproots. So what happens is at the top when you have that exchange of gases, it creates a pressure gradient. And because of that pressure inequity, right, water is allowed to kind of is creeps up the plant. Also because they can stick to each other and they can stick to the vessels of the vessels of the plant as water is also a solvent, right? So because it's polar, it makes a good solvent. So water molecules, like you see here, surround them. They can surround ions. So you can, even though it appears as though, they're great in solutions, sugar solutions, salt solutions. They're a solvent. They're polar. Because of that, they can kind of attract and surround different molecules. Like you have salt there. They're kind of busting up the salt molecule into chlorine and sodium, and they surround it in a way that makes it a good solution. So what dissolves in water? Something that we call hydrophilic, right? They love water. If you think of like the word like file, right? Like I'm an audio file. Like I love music, right? So that means that they love water. So the hydrophilic, hydrowaterphilic love water. So the polar substances are going to dissolve no problemo. Salt, sugar, those are going to be your polar substances. Things that ain't going to dissolve in water are going to be your nonpolar. So remember, nonpolar means they do not have. So polar means you have an unequal charge. Nonpolar, you got an equal charge. Nonpolar is like, cool, I'm good. I don't need you. I'm oil, I'm butter. They're not into water. Hydrophobic, phobic meaning scared. They're scared of water. All right, ice. So most substances, when they are a solid, they become more dense. Those molecules lock together, and the space between those molecules shrinking. Not with water. So actually, what happens is when water becomes a solid, its density decreases. That's why we see ice floating. And you look, because of these hydrogen bonds, while they're not strong, they are stable. So they don't need liquid water is all hanging out together. With ice, it's like, we're cool. It kind of expands. That's why we have cracks in the sidewalks, or we've got those big potholes we see every year, on the Edens after winter, because ice gets in our concrete and then it expands. What? So it doesn't necessarily shrink. So ice will, those bonds kind of like keep them at a stable pace, and it also increases the space between the molecules, which then decreases the density because there's less molecules there per square centimeter. So we need ice to float. We cannot have our oceans and lakes freezing. Okay, that can't happen because we've got marine life that needs to live. We have the marine fauna that needs to live, the plant life that needs to live. We need to have them stay at some point or in some capacity liquid all year round. Now you also have things like saltwater and climate that facilitates this in the movement of the oceans, but ice floating is key because when ice floats, it goes up to the top of the lake or the ocean, and it allows almost like for insulation for the plant animal life below. Okay, the last two are going to be high specific heat. Water resists change, right? Water's like your grandma. Doesn't want to change. Why can't things just be like they were before? I didn't have cell phones. Okay, your water also is probably like me. So it takes a lot for water to heat up, and it takes a lot for water to cool down. This is vital when it comes to the temperature of the earth. Think about Lake Michigan. Lake Michigan takes a minute to heat up in the summer. So it's helped cooling. They always say it's cooler by the lake. It's cooling that part of Chicago, especially because if you think about it, Chicago, we don't have a lot of like plants and plant life and trees and forests to help cool the environment, right? We have a lot of, it's concrete, it's buildings. So that the Lake Michigan helps to keep it cool, but then again, it takes a lot for it to once it does heat up, it takes a lot again to cool it off. So then in the winter, you have the lake kind of helping to regulate our temperature and that it stays warm for longer than you might think. So it also has a high heat of vaporization. which means it takes a lot to get this into the gas state. This is important for Michael Jordan, who apparently is sweating Gatorade, a lion, and your cute little friendly dog there. So because of this, sweat helps us to regulate our body temperatures, right? We are not lizards. We can't just go out and sit in the sun and, oh, it feels better, and then we go inside when we're cold. We have to regulate, mammals have to regulate our body temperature. What I was saying was reptiles don't. They require the environment to regulate their body temperatures. Because we need to rely on ourselves, we need to rely on water to store that, and basically to store that heat, and then to get it out of our bodies, right? Sweat is the way of us maintaining our internal temperature. Okay, there were some videos if you want to watch it. No pressure. We might watch these in class, so hold off on these. All right, that's basically it, guys. I know you're riveted. You're probably riveted, and you're probably just like, man, I could use some ice water. Okay, all right, till tomorrow.